Bom, como vocês sabem, estamos a viver tempos muito conturbados por causa da pandemia, do ponto de vista de medicina. Portanto, o Covid-19 está claramente a afetar praticamente todas as áreas de negócio de todos os setores de atividade e também com impacto social tremendo e, infelizmente, também com o impacto que temos visto, não só no nosso país, mas no mundo todo, relativamente a percas de vida. E, portanto, ouve-se muitas vezes falar deste conceito do novo normal e aquilo que nós pretendemos, efetivamente, é, na medida do possível, que esse novo normal seja um bom novo normal. O que é que isto quer dizer para estes temas aqui da inteligência artificial e do machine learning? Temos que ter consciência que realmente o mundo mudou. Quando estamos a falar de problemas de inteligência artificial e de machine learning, temos que ter a noção que existe efetivamente mudanças muito drásticas do comportamento dos clientes, dos nossos consumidores. Neste conceito do novo normal, temos que ter a consciência que existe um conjunto de alterações, existe efetivamente dados que são diferentes. Houve uma alteração substancial de dados, por exemplo, relativamente a março, abril, como podem ter a noção com o início do lockdown nos diversos países e na alteração também do comportamento dos nossos clientes. E toda essa informação leva a que tenha que haver a necessidade de haver uma alteração muito grande relativamente à aproximação que fazíamos do ponto de vista metodológico ao passado. O que é que as organizações pensam neste momento para este novo normal? Por um lado, muito importante a componente dos recursos humanos, repensar capacidades do ponto de vista da gestão da equipa. As equipas estão deslocadas, não estão próximas, isso causa uma transformação muito grande daquilo que é o modus operandi. As organizações têm que estar preparadas efetivamente para percorrer uma maratona, mas esta maratona, o caminho vai ter diversas alterações, o rumo vai ser alterado até chegarmos ao fim, à meta, portanto temos que ter essa capacidade. Temos que ter o conceito do ponto de vista da organização e do ponto de vista de recursos humanos dentro da organização, que temos que dar o salto para um novo conceito de agilidade, porque vai depender muito desta adaptação da sobrevivência de muitas organizações. As organizações também estão muito preocupadas com os temas todos que têm a ver com governance, muito na forma geral, mas também muito aplicado aqui aos temas de machine learning e também a componente de escala, porque é efetivamente necessário que as organizações tenham essa capacidade de conseguir chegar a materializar o maior número de problemas de machine learning e responder e ter a capacidade de passar do laboratório para a operação. E para isso é necessário também que exista confiança, é muito fundamental dentro das organizações que haja confiança naquilo que é produzido pelos data scientists e pelas ferramentas de machine learning, que exista um trabalho de equipa, portanto, cada vez mais isto é fundamental, que as organizações tenham que ter a noção que os data scientists não trabalham standalone, o negócio não trabalha standalone, o IT não trabalha standalone, e fundamental também, não só no conceito da economia circular, mas também aqui na componente de reutilização de dados, reutilização de best practices, e todas essas componentes são fundamentais para este novo normal. Onde é que está o maior valor dos data scientists? Portanto, é claramente uma questão fraturante, o tema não é aqui discutir hoje se aquilo que vamos apresentar se é certo ou se é errado, mas é claramente dar a entender que na definição do problema é fundamental a presença do data science. Aqui é que ele pode, de alguma forma, bem como na componente seguinte, de perceber esse problema, de transformar esse problema de negócio num problema que possa ser resolvido por um modelo de machine learning. É fundamental também na preparação, na procura, na preparação e na coleta dos dados para poder resolver esse problema. Também um papel fundamental na sua análise dos vários modelos, na explicação e na própria performance, bem como também na monitorização e apoio ao governance. Como podem ver, todas estas componentes que eu pus aqui estão um bocadinho fora daquilo que é muitas vezes considerado o papel principal, que é a componente matemática e estatística ou a componente mais de programação. E porquê? Porque essa componente, uma boa parte dela, hoje em dia consegue ser automatizada, retirando aqui as tarefas mais repetitivas e com relativamente pouco valor acrescentado. Essas sim podem ser automatizadas e é isso que nós depois queremos demonstrar. Porquê o Auto Machine Learning? Primeiro, hoje em dia são conceitos e ferramentas que já estão muito maduras, portanto não estamos a falar de uma coisa que surgiu há 2, 3 anos, estamos a falar em abordagens que já existem, portanto, o Data Science já existe há muitas décadas, mas estas componentes de Auto Machine Learning já existem há pelo menos 10 anos, portanto, claramente maduras no mercado. É fundamental aumentar a produtividade dos Data Science. Portanto, o AutoML não é para substituir os Data Science, é para lhes dar ferramentas, metodologias de trabalho que tornam o seu trabalho exponencialmente mais produtivo. É eliminar as tarefas repetitivas no life cycle dos modelos. Todas as componentes Feature Engineering, Training e Evaluation podem ser feitas de forma automática. Muitas vezes é um problema que existe nas organizações ou pelo código que foi feito para o modelo em laboratório não ser compatível com aquilo que é o ambiente de produção. Portanto, é fácil a passagem de laboratório para produção com estas ferramentas de AutoML. A componente de escala, mais uma vez, com a operacionalização dos models. Toda esta componente de management e monitoring é fundamental, um bocadinho como tínhamos visto no princípio da apresentação, onde vimos claramente que o novo normal obriga a que exista uma monitorização dos modelos, a sua performance, se não há data drift, por exemplo, relativamente ao seu comportamento, bem como também a sua assertividade dos próprios modelos. Mais uma vez, human-centric, portanto, o que eu quero dizer é que não vamos substituir, mas vamos trazer ferramentas para aumentar a produtividade. É fundamental o papel dos data science neste processo. A partilha de valores, porque hoje em dia estas ferramentas conseguem alinhar um bocadinho, que é um problema e é uma preocupação que existe muito premente hoje em dia relativamente aos BIAs dentro do Machine Learning, portanto alinhar isto e partilhar os mesmos valores que a organização tem dentro dos modelos de Machine Learning. Mais uma vez a componente de governance e de confiabilidade, fundamental para que exista uma mais-valia perceptiva e efetiva dentro das organizações. Muito alinhado também com os pedidos que as organizações têm, cada vez querem mais modelos, cada vez há mais casos de usos que são pensados e cada vez querem nos pôr mais rápido, portanto todas as questões de time to market são fundamentais. Bem como também, nunca esquecendo toda esta relação com compliance, é fundamental que tudo o que sejam as regras de compliance sejam também alinhadas dentro dessas ferramentas de Auto Machine Learning e a interação fundamental com o IT, de forma a garantir que todos os modelos que são testados e validados e que são bons para pôr em produção, se consigam pôr em produção de uma forma muito rápida. A plataforma DataRobot, assim em 2 linhas, por assim dizer, é uma plataforma end-to-end, como podem ver, com uma componente do lado esquerdo do AI Catalog, tem também uma outra ferramenta de Data Preparation, tem todas as componentes de Feature Engineering, até efetivamente pôr os modelos em produção e, muito importante também, a parte das aplicações da AI, bem como também a componente dos casos de uso e da valorização dos mesmos. Todo este ciclo de vida, desde os dados até ao valor, são efetivamente governados e trust. Existe esta plataforma que permite ter diversos tipos de utilizadores, de forma a ser claramente uma plataforma para a organização no seu todo, desde os data engineering, logicamente, os data science, desde também as componentes dos analistas de negócio, à componente do IT, como também à componente dos executivos que querem de alguma forma monitorizar e valorizar aquilo que estão os modelos em produção. Hoje em dia, as organizações em Portugal ainda num grau de maturidade diferente, mas noutras geografias com um grau de maturidade maior, já com muitos projetos na cloud, é fundamental que esta plataforma possa estar nos principais players. Há também, inclusivamente, quem tem ambientes híbridos, e isso é fundamental que seja conseguido alinhar com esta plataforma também, bem como também ambientes multi-cloud. E o facto de ser também open source, os modelos que existem dentro da DataRobot, como podem ver, incluindo os próprios da DataRobot, são open source, de forma a que exista efetivamente a componente de pertença à organização dos modelos que são construídos. É fundamental que as organizações detenham efetivamente o centro de competência e a competência para pôr a AI a funcionar end-to-end dentro da organização, portanto, desde o princípio até ao fim. Perceber aqui que funciona para todos os papéis que normalmente estão associados a um ciclo de vida de um projeto desta natureza. Fundamental também criar aqui alguma independência que pode existir em alguns cloud providers de alguma forma tentar bloquear a detenção do know-how e do valor relativamente a isso, e o facto, como eu tinha dito há pouco, de os modelos serem open source, portanto claramente otimizados para a organização, e que a organização fica detentora dos próprios modelos que vai pôr em produção e monitorizar.
Today I will be running a demo of the platform, basically credit risk use case, credit risk problem. So basically we will demonstrate how DataRobot can solve a business problem from the scratch, from the very beginning, using a raw data set with a basic machine learning problem or data oriented to machine learning problem. Ingest this into the platform, get some insights out of the model, and productionize this model in production. And we will be running this in about half an hour, more or less. Okay, I'll start by sharing my screen right now. So what you are seeing now is the DataRobot cloud-based platform. So essentially it's accessible through a browser, as you can see. Our cloud-based platform is based in Europe, is hosted in Ireland, but basically there are other options to install DataRobot on-prem as well, or virtual private clouds and so on. So essentially the first step obviously is ingest the data into the platform. And with that purpose, DataRobot has a built-in capability of data management. So instead of just accessing our local system to ingest the data or connect, for example, to a Hadoop cluster or another S3 cluster, for example, we will basically click in the data management capability, which is AI catalog, as you can see. And basically, this is the catalog where basically we have all the data sets that we are gathering. So for this one, this is a credit risk problem, as I say. So basically, I have previously named this in a particular way, so it's easier to find. The problem is about lending. So it's essentially we want to identify probability of default for potential applicants for our loans. So selecting lending here, I have a number of data sets, and this is the one basically we will go for this demo, Lending Club data set. So I'll create project using it, which is basically what I am doing now. And as you can see, this is a guided process. So DataRobot is informing us of this process. On the right side of the screen, a number of steps are going through. So essentially, first of all, the data is getting uploaded. And once the data is uploaded, as a best practice in the data science world and in machine learning, essentially, DataRobot automatically will perform an exploratory data analysis, which is basically what has been done now, as you can see, in 2 seconds. This is a task for those of you who are experienced in data science. Normally it takes few hours. And DataRobot has applied the best practices in this approach, and essentially has done a few things that are normally addressed by data scientists manually. First thing, we can see this table. This table corresponds to the data set we ingested. Originally was raw, but DataRobot has applied some techniques straightforward. So first of all, has identified the variable type. So you can see that the variables have a variable type here. Can be numeric, categorical, can be text, for example, or the variable type has been identified straightforward. So also for the numerical ones, we have some statistics like mean or standard deviation or medians, mean and maximum values. Identify also the missing values on the variables. If we deep dive into one of the variables, let's say loan amount basically is numerical variable, and you can see the distribution. All these things we are seeing now are basic, exploratory functions. No machine learning at all so far. So first thing we have to do in order to start building models out of this data set is identify the target variable. For those of you who are not familiar with machine learning concepts, the target variable in the context of machine learning means what we want to predict. It's basically a variable that we are using in combination with our historical records to identify, in this case, this is a credit risk problem, probability of default or propensity of default for future applicants. And this is basically the target here. So the target is telling us the number of applicants in our data set that defaulted, which is basically represented by this one, versus the ones that did not default. So essentially, we will use this as a target. So we go to this box at the top of the screen and enter the name of the variable, which is this bar. And DataRobot automatically has done two things for us. First one is identify this problem as a classification problem, as you can see. Then identifies or let us know the the balance of classes. So as we saw a moment ago, so many zeros and just a few ones, which makes this a kind of unbalanced problem, which is very typical in classification problems. Say that we are ready now to start building models. If anyone in the room now is a data scientist, they might be asking us about more technical details or deep dive into the details of the configuration of this particular problem, and that's possible using advanced options or a manual, setup in the platform. So essentially, for data scientists, there are always ways to deep dive into the configuration of the models we are going to build. But this is not something we will do today because this is a high-level demo. So essentially, we want to do this in autopilot way. That means we will start building models automatically using the best practices from machine learning world. There are 400 data scientists in DataRobot, and best practices from all these data scientists are into the platform to build these models. So next step, obviously, will be click this big star button here, and we'll start building models automatically. So let's do that. Okay, so moving on, you can see now that, again, at the right side of the screen, we have this guided process again. So DataRobot is applying some configuration on the data, and right away we'll start building models out of the data as well. So this is again a guided process, and as you can see, there are a few changes now comparing with the data set that we ingested a moment ago. So first thing is now DataRobot has added this green bar as one additional column. This means predictive signal. So essentially, the data or the columns are ranked by predictive signal. That means how good is the data to make predictions, or how influences each of the variables in order to to make predictions out of the data we are using. So from this point of view, and in this point, the most predictive one is the interest rate, followed by grade and subgrade of the loans, which makes sense actually for this kind of problems. And right away, as you can see on the right side, DataRobot has started already to build models. So there are a number of models, as you can see, 2 models, and there is a queue of models that are going to be built right away. An interesting point about this, and has to do also with the settings and configurations, is that this number at the top right, you can see we have a 2. This number has to do with which call workers. Workers is computer capability or CPU. So the more workers we have, the more capability we have to build models in parallel. Or what is basically the same is the more models we will build in less time. This is an equivalent whether we have a team of data scientists working in the same problem using different techniques. So as you can see, I'm increased this to 20. And now the workers that are being processed is being increased as well. This is basically scalability. So if we have a team of just few data scientists and we want to build more models, we hire more people. In data science world and DataRobot world, which is automated, what we basically do is just increase this number, and we basically will reach the same. Because this is interesting, because in the kind of world of the models, or the scenario of the models we built, which are basically all these you are seeing here, each model is applying a different technique to solve the problem. So you can see that we have a list of models, and the models are being ranked. This is why we call this also the leaderboard. Leaderboard is basically like a race. Every model is being trained in the data and validated in part of the data as well, which is basically a best practice in data science. And the more data is used for training, normally the major improvement we have in the validation in the green side of the data here. So the idea and the final focus is have all the models trained in all this blue area plus the gray area here, validated in the green part, and in the red part, or the red partition of the data as well, which is the holdout. So eventually we will have a number of models. As you can see, more and more models are being trained. If we, or DataRobot identifies that a technique works properly to train a model, basically, continue training this model in more data. And that way, basically, we end up having the best models that have been trained in more data and using a technique that works. That's the final idea. So, okay. So let's deep dive into one of these models to see what we've got. This first one, which basically we have here, has trained only in 32% of the data. So this is not the final view of this model, but the model is getting trained, and so far is the best one. So what you are seeing here is something we call blueprint, which is a graphic representation of the end-to-end flow of the model. Since the data is ingested, raw data, some feature engineering is applied. If you remember, we have categorical, numeric, and text variables. So essentially, different techniques are applied. As I said, every model is using different techniques. And eventually, the algorithm basically runs the predictions, and that's basically the final part. If we see more detail this, we can evaluate the model. And this is, again, that's something that is a standard in data science. We can evaluate the quality and performance of the model from different angles. As a data scientist, normally, I go to the evaluate, leaf chart, and ROC curve. And essentially, I compare predictions versus actuals, which is basically what we have in the screen right now. Or I look into the ROC curve, which is basically the confusion matrix, and calibrate the model. This is basic calibration. So for those of you who are familiar with data science and machine learning, obviously in classifications, you need to calibrate the model, because you need to decide how sensitive the model is to positive or negative classes. But this is a little bit more technical. So the idea is to calibrate the model, decide the threshold that makes sense for your model, and then get the insights or out of the model, basically, or get the explainability of the model to understand what the model is delivering. It's not only about how good is the model, but why the model is good, right? And what is the model delivering? And that's the focus of the understand tab here. So in order, because you can see that this, in order to keep the performance of the models high, DataRobot does not compute this automatically. And basically, what I have done before this session, I computed this in another instance of DataRobot, because you can create multiple instances. So essentially, this is exactly the same model, but that basically, as you can see, have computed everything for all the models that we built. So we will see a little bit more about this kind of understand and the different options we've got. So for the first one, you can see here is the featuring path. Featuring path is telling us the quality, the importance of the variables in the context of the problem we are trying to solve. So essentially, for this particular problem, we have elements and variables that make sense in the context of a credit risk problem. So for example, annual income, or description of the loan, or interest rates, those are the variables that work the more. So essentially what this is saying is that the annual income basically has a high importance in the context of someone to default at some point over the life cycle of a loan. That's the idea, right? Description is interesting because description has to do with the raw text. If you remember, we also had raw text in the data. And for that particular insights and explainability, we had this tab here. So for text, DataRobot applies text mining techniques, and this is really interesting and useful for the business. Imagine that someone is applying for a loan and you also have a free text box so people can basically enter the reason why they want a loan, right? So what basically we do is analytics on that. So essentially, we identify probability of default based in the expressions and words that people use. So here we can see that people using business or borrower frequently are more connected to default cases. And you can see this, for example, I think that we also have some others like, let me see, employment title. This is quite nice because I like this one because this is the employment that people add when they apply for a loan. So this one is interesting and this is real data. So this is based in real scenarios. So people that normally do not use employment title, which basically means that people that are not saying what they do for job or for living, are more propensus or have higher propensity to default. So essentially, when people do not want to say what they do, it's for something. That this is what this is saying, right? And on the other hand, we have people working in corporations or universities that are better because this is blue. That means that are less frequently connected to default scenarios. So moving on, again, into the insight side, we were talking about the feature importance, and we also have the predictions explanation, which is also great in terms of explainability. What this is saying is, let's consider this all the prediction distribution we have for the predictions of our model. So this is showing a snapshot of all customers, which are basically at the highest part, which essentially are the customers with highest probability of default, versus the ones that are at the lowest part. And these are the reasons. So essentially, you can look into the details of, for example, title, which is the reason why they wanted a loan, again, text mining, the term, which is very high, the description, again, text mining, the loan amount, and so on and so forth. So essentially, this is telling a story that is nice to tell and will give the business a better understanding of the reasons behind the people, doing a default and make the decisions out of that. So let's move on. Next step would be, once we have decide that the model is the best one that we can have and the explainability is great and is the model we want to deploy to our production environment, essentially we have this option, these predict options and deploy to do that. This is very straightforward. It's really simple. So the only thing you need to do now is, again, you have here you have the option to decide or choose a different threshold. I won't do that. And just deploy the model. And as you can see, again, this is a configuration step. We have different configuration options about, we will see this in a moment. This is the process, or this is the move that will allow us to put the model in production. So essentially, we need to decide if we want to apply data-driven techniques. We will see this in a moment, which is something we want to do. So essentially, I select this option and the accuracy as well. So this means that in the future, I want to measure accuracy over time. So the model now is proved to be valuable because basically we have identified that the accuracy is good at modeling time. But this is to test if the model continues to be good and having good performance in the future over time. Comparing the accuracy the model had when we built it against the accuracy the model is continued to have with future data sets. And for that purpose, I just need to enter here this ID. And I'm also going to enable challenging models that we will see in a moment. This is great for simulations. And that's it. I just click in create deployment. For governance, this is also important. Not all the models have the same degree of criticality. So for this one, I'll choose low. Obviously, there are other options here. You can have a model that is critical for your business. So you can have this option checked, and this will mean that the model will have to pass through a specific approval process. And then create deployment. And as you can see here, this is, again, a guided process. So this is automation, but basically the tool is informing at every step what is going on. Since this might take like a few minutes, I'll move again into a new instance of the platform, which basically all the models have been already deployed. This is what we call MLOps. So for your information, this is in the deployment tab. So basically it's the tab that we have here, right? So essentially, when we move into deployments, this is just moving from here to here. When we move a model into deployment, what we are doing is moving the model to a different endpoint, which we call prediction server. Each of our customers have a specific endpoint allocated. That means that your model will be allocated within this universe, this world, and will be you will be able to connect with your model via API. So it's simple and easy. But other than that, there are ways to identify the performance and quality of the models over time using this dashboard. So this has two different views. First view is global or general. You can see the quality and performance of the models all together, but then you can see in more detail the performance of the models entering into the detail of one model in particular. So if I do this basically, and we can see in more detail what that means for each of the models, we can see that we have, first of all, some governance metadata around the model, the story of the model, when the model was deployed, the owner, and so on. The service health, that is how frequently is the model used. These are the basic service KPI metrics. So the number of requests, consumers, whether we have some system or data error rates, because there were problems in the model, for example. The data drift, which is really interesting. Data drift basically is about the performance of the model by comparing the current state of play of the variables we are using versus the importance that the variables had when the model was built. So essentially that's important when, like in this case, some of the variables have drifted, have changed the actual importance versus the importance that they used to have. And this is shown in the form of a metric, which is the drift that is measured between 0 and 1. So if, for example, I select this one, you can see that the data that is being used for scoring, as you can see here and here, especially here, is so different to the data that we use when basically we train the model for the first time, which is something that is really important because eventually this will take you to a completely different result that you expect based on the model that you built some time ago. So you should be aware of this. And I have customers that, for example, now have created a new line of product, let's say this way, and they are now using this line of product for scoring. Basically, the model does not have any idea what to predict because it's the first time that the model sees this product. So we should be aware of that. And DataRobot will inform of this kind of changes and drift, because basically this means that the model is drifting from the original confidence interval. And this shouldn't happen in the modeling world. Accuracy is more about measuring performance of the models over time, as I said a moment ago. So over time, we can be, training our models regularly, but I have many customers that before DataRobot used to train their models with no control. So when you ask them, when you train your models normally, they say, okay, I train the models once a month or once every quarter, but they did not know why. The reason why you should train a model is this, because the model is getting worse. The accuracy is basically degrading. And you don't want this basically because that means that the model you have in production today is not the same model that you deployed 3 months ago, and that's not good. So these tools basically will give you the chance to understand that better. You also have other options like humility rules that basically are rules that you want to create to override the predictions based on complex understanding of the business for specific scenarios you basically don't want the model to predict. And also you have challenges. I think that challenges are great now in the context of the current situation and COVID, and even in the new normal, as we said a moment ago. So many customers are using this now. This means that you can create kind of A/B testing, for example, or simulations. So you can have a champion model, which is the model that basically you are using for your predictions. But let's say that you want to create simulations for other models that can be trained under different scenarios, and then you can put all of them to compete in a regular basis. So here you will see basically which is the model that is first. But let's say that one of the other models is beating your model. It's good that you also have visibility on that, right? Say that basically, the only thing I want to show you, basically, this is the model we deployed a moment ago. As you can see, when you deploy a model, everything is null because basically we haven't used this model yet. So the only thing I want to show you before we wrap up and close the demo is how easy is basically run predictions. You can do this using the API or using the user interface. For this purpose, I want to use one particular, a data set I have for scoring. And for this one, if I'm not mistaken, I think that I can use this one. Let's use this one. So this is a data set I have prepared before this demo, right? So the only thing I need to do is basically upload it from data management as you saw, and just create the predictions. And what DataRobot is doing right now is ingesting this into the prediction server platform, run through the model basically that has been productionized previously, and automatically the predictions will get out. And once the predictions are getting out, we will have all the different options updated, which is the reason of the MLOps basically is monitoring, right? Which is basically that. This is the predictions, or these are the predictions. And this is basically the actual outcome, whether the customer should be approved or not, very straightforward. And then if we move into service health, we see that now we have a prediction. And exactly the same. Well, for data drift, sometimes it takes a little bit, but eventually we will have also the predictions here. Last thing is in the configuration side. Let's say that you want now to upload the actual values, because obviously this is a simulation, but obviously we need to have the actual values in order to be able to upload this. So essentially, let's simulate that we have the actual values, and should be this one, make predictions actuals, and use this data set. The only thing we need to do essentially is select the same actual value and association ID, which is very easy, and just save changes. And what this is doing is basically telling DataRobot that this data set we are uploading right now has to be matched with the data set we use for scoring, and comparing both basically get metric out of that, basically comparing predicted versus actual for both files, which is essentially what we do at modeling time, right? Is essentially build a metric based in the comparison between the quality of the predictions versus actuals. And now, if we move into data drift, this has been updated already. As you can see, there are a few variables that are not looking good, like this one. And if we move into accuracy, again, we have this already set up. So this is the first time the comparison is showing that the models are going better, right? That's the idea. And the idea now is to start doing this over time, so you have more granular idea about how good our model is performing. We can create humility rules, challenges, and so on and so forth. Wrapping up, this is the final part of the presentation and demo. So I think that I'll be happy to answer any question that anyone can have right now. Very good question. So basically, DataRobot is a platform that, my personal opinion, I think that is the company's opinion, is that the investment in DataRobot makes sense if basically there is a return of investment assured. If you are using the platform, basically you are getting money. It's not an expenditure, basically. That's the idea, right? So everything we do is very much focused in assuring that our customers return the investment in the product. And focus on that, basically, we focus very much in use cases. So use cases, every industry is different, obviously. Now we are supporting a lot of customers. Let's say banks, okay? Banks now are struggling with for many different reasons. So we try to focus in the specific use cases that can have a major impact in the business. And for that, essentially, we meet with data science teams and also with the business people and try to identify the pain points they have currently. So for example, in the context of banks, as I said, and this is just an example, a customer told me the other day that they are struggling now with credit risk decisions. Like, for example, this demo we saw today, because it's so difficult now giving loans to customers because there is no visibility on the risk assessment right now, because here in the UK where I live, basically, customers are taking payment holidays. So we are now supporting them in order to identify the impact of this particular credit risk models we are building for them with the business side. This means that using different assumptions, you estimate how much impact the model or the use of DataRobot and having a model with a specific accuracy can have in your business. Out of that, basically, you get an estimation of the potential ROI you can have. This is an estimation because the ideal way of doing ROI estimation, obviously, is doing a kind of A/B testing. I do something and I compare this with doing nothing. And over time, I basically estimate the return of investment for me. But with DataRobot and machine learning models, basically, we try to do this assuming something, and that normally works very well with our customers. So this is our essentially our way of working. So essentially, in terms of productivity, again, I'll talk about some examples and scenarios of use of the platform. What we do normally is work with potential customers in the form of proof of concept. And one of the tests that we do is how long do you normally take in doing a specific task, and how long to do the same basically using DataRobot. And our experience, and this is what the customers tell us, is that DataRobot boosts productivity in at least 15 times more for some of the tasks that they are normally doing. That can be, for example, if for you putting a model in production is a combination of factors, obviously, but as an average, it takes like 2 or 3 months normally. As you saw this in the demo today, with DataRobot, that's really easy, right? So you can have a model in production much faster. And doing that across all the different parts of the model's life cycle, the effect and the impact is massive, because data scientists that end up learning how to use DataRobot properly can also focus in other tasks that have higher impact on the business as well. So it's difficult to measure, but I'd say that all teams that now are using DataRobot as an automated machine learning tool has experienced this. And I'd say that as an average, the productivity now has increased, as I said, in maybe 5 times less as the very least. And that's the way it works, basically. Yeah, that's a really good question as well. I mean, democratize is a concept that is it's general, but at the same time is like very specific for automated machine learning. And DataRobot use it a lot because basically our focus, we work with data science team and machine learning teams, but we also have put the focus a long time ago in the democratizing data science. So that means what you have seen today in this demo, that anyone can do that, right? Any business analyst with a clear understanding of business concepts can basically just ingest the data into DataRobot and just click the button. That's the idea, right? The idea is that anyone can use or can build models. A few years ago, when I started working as data scientist 10 years ago, you normally work just with statisticians or mathematics people. This kind of people used to be involved in data science. Nowadays, with DataRobot, basically, a business user can build models, and that's great because essentially you can have people from your department that is actually the people who actually knows your business, focus in building very good models. That was one of the caveats of data science work, for a long time, was that data science or data scientists and machine learning engineers basically did not know your business that well as your business people. And with these, capabilities I mentioned, we are basically bridging this gap, which is great. Basically, there is a limitation for the cloud platform. I'll go for the generic answers. Okay, we should see more detail for each of the scenario we are talking about. But normally for the cloud platform, we have a limitation of 5 GIPs. For on-prem solutions, which is basically installing on-prem the platform, is around 10 GIPs. But we also normally have a technical discussion with the customers and see why exactly. First of all, it's important to understand the size of the data we are looking at, whether it makes sense or not, ingesting a data of much size into the platform because of any problem or any criteria, because our experience tells us, and there are different capabilities in the tool addressed to that. Our experience tells us this is an option or a functionality we have to basically show up if the platform, basically, you can see sample size at the bottom. If the data is going, or the model is going better with more data. So what we suggest normally is do an analysis before deciding if it makes sense to add more data, because adding more data in general terms used to mean more money, because obviously you need more computation, and having more computation has a negative effect in the performance and also in basically in the hardware you need, right? So everything is connected, as you can see. So our suggestion, first of all, is doing an analysis on your problem. Start by small data and continue to grow your data until you see that there is not improvement. Because I had a conversation very interesting 1 year ago with a customer in Italy. They wanted to ingest more than 100 GIPs. And essentially, what we demonstrated using similar techniques is that the model performance was flat, or above like 3 or 4 GIPs. So basically, they were trying to ingest more than 100 that they did not need, right? That's the thing. For the model to capture the trends and indicators, is possibly you will need much less data. But I'm not talking about this from a generalistic point of view. I like to understand the problem, right? But 95% of the cases, I think that data is the, more data does not mean a better model. That's what I mean. So basically for monitoring, that's a very good question. Monitoring, essentially, my suggestion always is deploying the models and have a plan to monitor over time. And that used to mean, first of all, using the challenger models is great. So essentially, you can have like a threshold beyond which you basically, each model, depending on the criticity and the governance I mentioned before, some models are more sensitive to failures, right? So you can define this at configuration, at settings. So you define the sensitivity of your model to failure. That's great because essentially once you have defined that, and you can also define notifications. For example, let's say that you want to receive notification when a model is going beyond a specific threshold for drift or accuracy, you will receive this notification and you will make the decision to replace this model if it makes sense, right? So that's the idea. The idea is to have a complete bunch of capabilities to make sure that the model in the production at this point of time is the best one you can have, and decide what is the best moment basically to replace the model. And all of that is governance and monitoring, as you can see. So that's the ideal methodology. Okay, I understand transformation agent in the sense of the difficulty of sometimes when we want to essentially do or perform a transformation in our organization, and I face this every day, right? So companies that have been doing analytics in the past or have been doing BI, for example, and then they want to evolve, and that means transformation and change, and that's not that easy. I think that is a combination of a number of factors. First of all is education and enablement as well. So it's making sure that your people understand the benefits of using AI is critical. In my experience working with technical teams when I started working in DataRobot 3 years ago, there were some challenges and pushbacks from some technical teams that they basically thought that using DataRobot could be kind of a threat for them. And eventually when you talk to them, they start to see the platform more like a help, a support, more than a threat. That's the idea. The idea is to support them, understand their pain points as well, and start working in their enablement step by step. And at some point, they will see AI like basically something that is here to stay. That's the first thing. And that is here to help the organizations, basically, both technical side and business side, to make our lives easier. So for COVID, that's a very classical question and topic nowadays, right? So first of all, it depends on the business, because not all the business not are struggling with a COVID situation in the same way. It's not the same a retailer or a bank that an airline, for example, right? So the first thing I think that is understanding the complexity of the situation and how your business is impacted. And then is building a plan, basically. Building a plan, as I said before, it means normally in the context of machine learning, identifying pain points and use cases. Where you have where you are struggling more, basically. What are the actual problems you have or your business is struggling with due to COVID, right? So once you have your plan in place, is essentially you have to identify how AI can help granular detail in each of these different pain points you have, right? So we are working with, for example, in Spain, we have an airline who is customer with us, and we have identified a number of potential use cases to help them. Obviously, the problems are there. AI is not going to do that. These problems will disappear. But these guys, for example, are now building models to do dynamic pricing that they never did before. For example, dynamic pricing means that they can decide a better price points for customers based in specific decisions. Like, for example, before COVID, they used to provide the customers with the same price. Now they can adapt the customer profiles. Like, for example, business customers are able to pay more because basically they have more money, let's say that way. Even now, business customers are not that frequent because of the lack of travel, right? But you can basically do a better price offer based in the profile of the customers and the segmentation of them, right? So that's the idea. The idea is to adapt the use cases a little bit and also capture trends, because essentially now customers have changed behaviors recently. So we have seen a lot of, more default or more frequently the problems of debt collections, but basically credit card customers. I have another one. I talked to them this morning, and they were having problems in the debt collection area because customers were using now credit cards. The customers are using less credit cards, but when they use credit cards, they use credit cards for things that they did not use to do it before, right? Like building, for example, to buy food or things like that. And this is causing more frequently default problems. So again, understanding the problems from the very beginning, talking to the business, and then adapting use cases to the new situation. And AI will be there for help. That's the objective and idea. Okay, forecasting models, I guess that we're talking about time series, right? Okay, for forecasting models, we won't have time to show this today, right? But if you, after the session, if you enter DataRobot community, that's something that basically DataRobot has for all customers and non-customers. So essentially, it's a way of everyone to be connected around DataRobot world. And one interesting one is the time series. So time series basically is another capability that DataRobot has, and actually has a lot of interest for the situations around COVID. So if you enter, and I show in this because basically we won't have time to show this in the platform, you will see that DataRobot also includes certain capabilities. This is what we saw before, right? But for time series models, basically DataRobot has an additional configuration step, which is this one. So essentially, you should have obviously for time series a date feature, date variable. You select the variable, DataRobot detects the stationarity in the data essentially, and then you can decide the forecasting point and derivation window, which is what we are doing here. And this is the forecasting thing, right? So basically, what we are doing here is I'll take data from the last 30 days before the forecasting point and forecast 7 days into the future. So every day, basically, I forecast 7 days. That's the idea. And just the next is very similar. The only thing is that DataRobot will build a lot more models with time series, a lot of more feature lists, but basically is variables that are created automatically, feature engineering, and build the models. But as you can see, the models are time-based, right? So this is the additional concept. But the other stuff is very similar. The lift chart you saw a moment ago is predictions versus actuals in the time series world, and forecasting is different because it's time-based again, right? But other than that, the user interface and everything is very similar. So yes, I think that time series is great now to handling a COVID situation as well. A little bit as I explained it before with the cultural thing, right? It's like it's just trying to make sure that the people understand what AI means, which is something that is not that frequent nowadays. People start to think more in AI way, right? Because we are seeing or talking about AI everywhere. The important thing here is like AI has a right to stay. It's not something that is temporary. It's something that basically in the future all companies will use AI. That's for sure. It's a matter of when, but it will happen, yes or yes, right? So that's the idea. And it's when 1 century ago everyone was basically using horses, and then some people started to use cars. That's the idea. The idea is that there is an evolution, and you better be in the side of the evolution because basically you can leverage the evolution better. And make sure that your people adapt to the evolution at the same time that you do. So your company is moving forward faster. That's the idea. And how to do that is basically a matter, again, of education, talking to your people, making sure that everyone is understanding the same that you understand, is having the same mindset. And moving forward, one of the things and with that I basically wrap up, one of the things that DataRobot does, and this is a clear differentiator of us as a company, is we spend a lot of time working in the enablement of our customers. So we have a lot of capabilities. For example, we have something we call DataRobot University. DataRobot University is basically a portal that we have specific to train our customers. And it's very much addressed to train our customers in different aspects of the platform and machine learning as well. So if you guys want to enter into the university.datarobot, you can basically register yourself. It's very easy. And then you will see that we have like learning paths. Learning paths are, some of the courses are free, by the way, some others don't. But essentially, you can identify a basic learning path for you or the people in your team, for example. And then essentially, once you have selected your learning path, essentially, you can move forward having these enablement sessions. And move forward is trying to just, understand better the machine learning concepts and how DataRobot or how machine learning can help you to or can help your business. That's the idea.